Dear students, welcome to our next fluid mechanics class. So last class we seen three-dimensional continuity equation. Okay. So once again I remember that equation. So it is nothing but dou u divided by dou x plus dou v divided by dou y plus dou w divided by dou z equal to 0. So this is the continuity equation. Okay. So in this class we will discuss the problems in the continuity equation, velocity potential and stream function. Okay. So let's go to the class. So first problem. I read the question. Please follow. The velocity components in x and y directions are u is equal to 2 by 3 x y cube minus x square y, comma, b is equal to x y square minus 2y x cube divided by 3. So here there are two velocity components they given. Okay. So what they asking, whether this velocity distribution is a possible field of flow. Second question, net a possible field of flow. Okay. So in this question they ask whether this one is possible fluid of flow or not. Okay. So for this we have to apply the three-dimensional continuity equation. Okay. So if you differentiate the partial differentiate this u and v, finally you sum of all those things. If you got 0 means it is a possible field of flow. So now we will check that one. Okay. So write u is equal to 2 by 3 xy cube minus x square and v is equal to xy square minus 2y x cube divided by 3. So this is the u and v given, data given. So now what is the, since only two values only given, u and v, the w is not given. So it is a two-dimensional flow. Okay. If w is given means that is the three-dimensional flow. Okay. So w is not given. So it is a two-dimensional flow. So now let us check dou u divided by dou x. Okay, dou u divided by dou x. So partial differentiate of this u with respect to x. So dou by dou x into 2 by 3 x y cube minus x square y. Okay. So now what is the differentiation with respect to x? Here x is equal to, we converted into 1 if you partial differentiation means. So balance thing 2y cube divided by 3. So minus x square if you differentiate means 2x. Okay. So minus 2xy. Next come to dou v divided by dou y. Okay. So equal to dou by dou y into, so what is the velocity function of v is equal to xy square minus 2y x cube divided by 3. Okay. So now differentiate this velocity function with respect to y. Okay. So y square if you differentiate means 2y. Okay. So 2xy minus, here only one y is there. So it is the partial differentiation of y means it is 1. Okay. So 2x cube divided by 3. Okay. So now summation of this dou u divided by dou x plus dou v divided by dou y. Okay. So now summation of these two values you can sum means, okay, here I written 2y cube divided by 3. Okay, 2y cube divided by 3 minus 2xy plus 2xy minus 2x cube divided by 3. Okay. So this minus 2xy and plus 2xy get cancelled. Okay, minus 2xy plus 2xy get cancelled. Okay. So now you add this 2. Okay, we can't get 0 because here y is there, y cube is there, here x cube is there. Okay. So it is not equal to 0. So hence it is not equal to 0. It is not a possible field of flow. So this is the answer. So if the answer is 0 means this is the possible field of flow. Okay. So next come to second question. So just you differentiate, partial differentiate the velocity components. That's all. And finally, you have to add. So next come to second question. For an incompressible fluid. Okay. So remember, incompressible fluid means if you take water. Okay. So for an incompressible fluid, the velocity components are u is equal to x cube minus y cube minus z cube x. Okay. Next, b is equal to y cube minus x cube, comma w is equal to minus 3x square z minus 3y square z plus z cube divided by 3. Okay. So these are all the three velocity components. What they asking? Determine whether the continuity equation satisfy or not. Okay, same thing. Okay, as in our previous case. So in this case, there are three velocity components given. Okay, so we have to apply. We have to include W term also, W term and Z term also. So now write the given data. Okay, U, V, W. So U is equal to x cube minus y cube minus z cube x. Next, V is equal to y cube minus z cube. Next, W is equal to minus 3x square z minus 3y square z plus z cube divided by 3. So these are all the three velocity components. Okay, now apply the partial differentiation. So dou u divided by dou x is equal to dou by dou x. So now substitute u term here. So x cube minus y cube minus z cube x, which is equal to, so differentiate this term with respect to x. So here x cube is there. So partial differentiation of x cube is 3x square. Okay, 3x square. So next, here there is no x term. So leave it. So here one x term is there. So partial differentiation of x is equal to 1. So it is minus z cube. So the final answer is 3x square minus z cube. So next come to dou v divided by dou y. Okay. So dou divided by dou y and velocity component of v is y cube minus z cube. Okay. So now partial differentiation for this. So here only one y term is there. Okay. So here z term is there. So it will not come. So only this y term only will come. So it is partial differentiation of y cube is 3y square. 3y square. Okay. So now come to third velocity component. So dou w divided by dou z. Okay. So dou by dou z, substitute w term here. That is minus 3x square z minus 3y square z plus z cube divided by 3. So here where z term is there, see in all the three terms z term is there. So we have to differentiate. So if you differentiate, partial differentiate z means 1. So minus 3x square. So here also only z is there. So it is minus 3y square plus. So z cube is what? Differentiate. Differentiate means we get 3z square divided by 3. Okay. So 3z square, already denominator 3 is there. Okay. So now this 3 get cancelled. In that 3z square divided by 3, numerator also 1 3 is there, denominator also 1 3 is there. So get cancelled. So the final answer is minus 3x square minus 3y square plus z square. So this is the answer. Okay. So now the summation of all the three terms. So dou u divided by dou x plus dou v divided by dou y plus dou w divided by dou z. So substitute all the terms under sum up. Okay. So here 3x plus 3x square is there. Here minus 3x square is there. So get cancelled. So here plus 3y square is there. Here minus 3y square is there. So get cancelled. So what is the balance thing? Minus z cube plus z square. Okay. So minus z cube plus z square, which is not equal to 0. Okay, not equal to 0. So here also not satisfied. Okay, so it is not possible fluid of flow. Okay, so here continuity equation not satisfied. Okay, students. So I think all of you understand these two problems. So what you do, first write the given data. Next, write the formula. Formula means that continuity equation. Okay. Next, what are the velocity components are given? Okay, that you already written in the given data. Okay. So partial differentiation of the velocity component and summing up all the things. Okay, so finally the sum up value, if you got 0 means it is a possible field of flow, otherwise it is not a possible field of flow, continuity equation not satisfied. Okay student, let us go to next, velocity potential. Okay, so velocity potential, what is by velocity potential? So last class we discussed. So it is the negative derivative. So it is a scalar function of space and time such that its negative derivative with respect to any direction. Okay, with respect to any direction. So here the direction means they are telling x, y, z. The three directions. Okay. So the with respect to any direction gives the fluid velocity in that direction. So the symbol of velocity potential is pi. Okay. So now you can write u is equal to, this is the x-axis, x direction velocity. Okay, u is equal to minus dou by dou x. So negative derivative. So minus dou by dou x, and b is equal to minus dou pi divided by dou y, and w is equal to minus dou pi dou z. This we already see. So substitute these three values in the continuity equation. Finally, we get this answer. So dou square pi divided by dou x square plus dou square pi by dou y square plus dou square pi by dou z square, which is equal to 0. So this equation we already discussed in the previous class. So in this class we will go to the problem. Okay. Okay students, now we will see the problem. So verify whether the following functions are velocity potential function or not. So there are two functions. Velocity potential is given. Pi is equal to a, capital A into x square minus y square. This is one of the velocity potential function. So next, pi is equal to a into cos x. This is also another velocity potential function. Okay. So now we can check whether it is the velocity potential function or not. Okay, they given velocity potential. We have to check whether this is velocity potential, satisfies the velocity potential or not. Okay, so now let us do the problem. So here only x and y term is given, only two directions. Okay, they given only two directions. So this is the two dimensional. Okay, not three dimensional. Okay, so now take the first equation. Pi is equal to a into x square minus y square. So write the two-dimensional continuity equation. So dou square pi by dou x square plus dou square pi by dou y square equal to 0. So velocity potential continuity equation. So now apply this. So here it is square. So we have to do 2 times. So we have to do partial derivation 2 times. Okay. So first time dou pi by dou x. Okay. But we need dou square pi by dou x square. Okay. So first we will do dou pi by dou x. So dou pi by dou x into a into x square minus y square. So we have to derive. We have to do the partial derivation for x term only. So here what is the x term? X square. Okay. So if you partial differentiation x square means what? 2x. Okay. So here y term will get 0. So what is the final answer? A into 2x. This is the answer. So next we have to do one more time. Dou square pi by dou x square means again this x is uh, turned into 1. So final answer is 2a. Okay. So next come to y term. Dou pi by dou y. So first time we have to derive partial derivation we have to do. So dou pi by dou y into so a into x square minus y square. Okay. So now you can check. We have to do here partial derivation for y term. So here minus 2y. Okay. So minus y square is there. So we have to partial derivation to minus 2y. So already this x term will get cancelled. So already one a is there. So it is minus 2ay. So now dou square by dou a y square, which is equal to this y term turn into 1. Okay. So final answer is minus 2a. Okay. So now the summation of dou square pi by dou x square plus dou square pi by dou y square. So this is the equation we already seen. Okay, velocity, potential, continuity equation. Now we have the value of this term and we have the value of this term, x term and y term. Okay, so now what is the x direction value is 2a, y direction value is minus 2a. So the summation of 2a minus 2a equal to 0. So we can get 0. So this is a valid potential function. Okay, this is a valid velocity potential function. Now let us do the second question. Okay, so in this second question they given a cos x. Okay, so let us see second question. So now you can see pi is equal to a cos x. Okay, so this is the equation should satisfy. Dou square pi by dou x square must be 0. Okay. So here only x term only is there. Only x term. So there is no y term. So this is one dimensional. The flow is one dimensional. So first derivation dou pi by dou x is equal to. So what is the differentiation of cos x? Partial differentiation of cos x is a into sin x. A into sin x. Next is dou square pi by dou x square. Again you have to derive. Partial derive. Okay, derivation is what is the sin x differentiation? It is nothing but a cos x. So we didn't get 0. So if the condition dou square pi by dou x square equal to 0, once this condition is satisfied means it is the velocity potential function. But here you can see we didn't get 0. Okay, na? We didn't get 0. So this is not a velocity potential function. Okay. So in the first case, this is the velocity potential function, and the second case is not a velocity potential function because it is not satisfied the equation. Okay. So first term is satisfied the equation, but the second term it's not satisfied the equation. So it is not a possible velocity potential function. Okay. So understand, students? Simple. Write the equation, velocity potential equation, and substitute, and finally sum up. Okay. Do the partial derivative and sum up. Whether if you got 0 means it is a valid potential function. If you not get 0 means it is not a valid potential function. Okay, students. Okay, student. Next problem. Okay. So in this next problem, I read the question. The velocity potential function pi is given by an expression pi is equal to minus xy cube divided by 3 minus x square plus x cube y divided by 3 plus y square. So here they asked 2 questions. What is the first question means? Find the velocity components in x and y direction. So what are the velocity components here? So u and v. So first in this first question we have to calculate the velocity components of u and v. So in the second question, they asked whether this flow, okay, this pi is the possible case of flow. Okay. So in that equation, if you got 0 means it is the possible field of flow. So now we will check. Okay. So next, write the given data. Pi is equal to minus xy cube divided by 3 minus x square plus x cube y divided by 3 plus y square. Okay. So first we have to do the partial derivative with respect to x and y. Okay. So before going to the problem, for simplification purpose, for easy purpose, we have to periodly we have to do the partial derivation. So dou pi by dou x is equal to, so this is the pi value. So differentiate this, partial differentiate this value with respect to x. So what you got here, only x is there. So this term cancelled. So minus y cube minus, okay, minus y cube divided by 3 minus, here x square is there. So it is 2x plus, next 3x square y divided by 3 plus, here y term is there. So it is get cancelled. So this 3 get cancelled. Next come to dou pi divided by dou y. So differentiate this equation with respect to y. Okay. So here minus x 3, sorry, y cube is there. Y cube means we have to partial differentiation means we got 3y square. 3y square. So we get an answer 3xy square divided by 3. Next plus x cube here. X cube here, only x square is there. This term will not come. Okay. So here only y is there. So this term also changed into 1. Okay. This term will turn into 1. Okay. So only x cube divided by 3 only is there. Plus y square, if you differentiate y square means we get 2y. Okay. So these are the dou pi divided by dou x and dou pi divided by dou y. So now we will enter into the problem. So we know that, sorry, 1 minute. We know that u is equal to minus dou pi divided by dou x. So this is the velocity velocity components, okay, of u. Okay. So the formula is minus dou pi divided by dou x. Okay. So this pi value we already know, it is given in the question. Also we calculated the dou pi by dou x previously. This is the answer. Okay. So here one more term minus is there. So outside the bracket put minus and substitute this value. Substitute this value. So finally, if minus comes to inside the bracket means this turn into plus, and this also turn into plus, and this value is turned into minus. This 3 get cancelled. So the final answer is y cube divided by 3 plus 2x minus x square y. So this is the final answer. Okay. So same way for b term. So for b term we already calculated minus dou pi by dou y is equal to 3x y square divided by 3 plus x cube divided by 3 plus 2y. Okay. So here also minus term is there. If you come inside means finally we get an answer xy square minus x cube divided by 3 minus 2y. Okay, you can simplify this 3 get cancelled. So balance thing minus xy square. Next this minus term comes to inside means x cube divided by 3, and here also minus 2y. So these are all the velocity components u and b. Simple formula. Okay, minus dou pi by dou x. This is for x direction velocity components, that is called u. Okay, next minus dou pi by dou y. This is the y direction velocity component. It is called v. Substitute in that formula for the given velocity component, and we easily get the answer. So first question is over. What is the second question? Whether it is possible case of flow or not. So for that condition, we have to write the continuity equation. Okay, velocity potential continuity equation. So since only x term and y term is there is no z term in the question. So it is the two-dimensional flow only. Okay. So under this two-dimensional flow, we have to write dou square pi by dou x square plus dou square pi by dou y square equal to 0 because it is the two dimension. So we have to we have to do the partial differentiation in two times. So first time dou pi by dou x. This we already calculated previously. Okay, here you can see here dou pi by dou x and dou pi by dou y. We already calculated. So just write that one. Okay. Next, again we have to do the one more time partial differentiation. So dou square pi by dou x, which is equal to minus 2x. So we have to differentiate only in x term. So minus 2x differentiate means minus 2 plus 2xy. So this is the dou square pi by dou x. Okay. So please note down, only we have to do partial differentiation in x term only. So here only one x is there. If you partial differentiation x means you get into 1. So minus 2. So here x square is there. So partial differentiation of x square is 2x. So 2xy. Okay. So now dou pi by dou y. Okay. For dou pi by dou y, this also we already written. So again you have to differentiate. So dou square pi by dou y square is equal to minus 2xy plus 2. Okay. So here we have to do only y term. So minus x y square differentiation, partial differentiation means 2y plus here there is no y term, it get into 0 and 2y. Okay. For 2y partial differentiation is only 2. Okay. So finally we get an answer minus 2xy plus 2. So the summation of dou square pi by dou x square plus dou square pi by dou y square, you can write this term and plus this term. So now you can see here minus 2 is there, here plus 2 is there, get cancelled. Here plus 2xy is there, here minus 2xy is there, get cancelled. So the final answer is 0. Okay, so hence you have to write hence pi represents the possible case of flow. So this is the answer. Okay. So next we will see the stream function. So what is the stream function? Last class we discussed about the stream function. So it is defined as the scalar function of space and time such that its partial derivative with respect to any direction gives the fluid velocity component at right angles to the direction. So here please note the velocity component we can get at right angles. Okay. So it is denoted by psi. Velocity potential is pi, stream function is psi. Okay. So and also main thing is it is for only two-dimensional flow, not three-dimensional flow. Okay. So mathematically dou psi divided by dou x is equal to v. Okay. So here x term is there, but what is the opposite velocity component? It is v. Okay. Opposite means right angles. Okay. Next, dou psi by dou y is equal to minus u. Okay. So keep it, remember this only two equation. Okay. So next, relation between stream function and velocity function. So this also we already seen in last class. So in both velocity potential function and stream function, we have two velocity components u and v. So we can relate the both means we can get this equation dou pi divided by dou x equal to dou psi divided by dou y, and also dou pi divided by dou y is equal to minus dou psi divided by dou x. So these are all the relation between the velocity function, velocity potential function and stream function. Okay. So now we will see the problems in the stream function. Now you can see here a stream function is given by psi is equal to 5x minus 6y. 5x minus 6y. Calculate the velocity components and also magnitude and the direction of the resultant velocity at any point. So please note down in this question, they given only a two-dimensional stream function. Psi is equal to pi x minus 6y they given. What they asked, what are the velocity components? What is the velocity components? U and V. So they are asking U and V. Okay. Also magnitude and the direction of the resultant velocity at any point. Okay. So now you write the given data. So psi is equal to pi s minus 6y. So next for so we know the equation dou psi divided by dou x is equal to under dou psi divided by dou y. So now what is the partial derivative of this x term? Okay, so here phi x is there. So if your partial derivative of this psi is equal to phi x with respect to x only. Next here partial derivation of psi with respect to y is minus 6. Okay, minus 6. So now you have to write the velocity components, but the velocity components u and v in terms of stream function are given by. So what is the formula for stream function velocity component? U is equal to minus dou psi divided by dou y. Okay, so now dou psi divided by dou y we already calculated previously. Here you can see it is minus 6. Okay, so already one minus is there. So this minus get plus. Okay, so simple thing. First you differentiate. So first write the formula, U formula and V formula, and substitute psi value in this formula. Okay, so if you partial differentiate means you can directly get the answer. That's just a simple. Once you remember the U formula and V formula. Okay. Next, so it is 6 unit per second. Next, come to V term. So for the V term, we know this dou psi by dou x. Okay. So we are that one we already calculated. Dou psi by dou x is equal to 5 units per second. Okay. So next we have to calculate the magnitude and direction. So resultant velocity is the magnitude. Okay, resultant velocity is nothing but the magnitude. So the formula is root of u square plus v square. Root of u square plus v square. So now what is u? We already calculated. It is 6 square. And v means we are that also already calculated. It is 5. So root of 6 square plus 5 square, which is equal to 7.81 unit per second. So this is the answer. This is called resultant velocity, or sometimes it's called magnitude. Okay, magnitude of the velocity. Next come to direction. Direction means in how much angle it will flowing. So that is this is the formula for calculating the direction. Tan theta is equal to v divided by u. This is not u, this is v. Okay. So pi the theta is the angle. So tan inverse is equal to tan inverse of v divided by u. So what is v divided by u? It is nothing but 5 by 6. 5 by 6. So tan inverse of 0.8333. 5 by 6 is nothing but 0.8333. So the final answer theta is equal to 39 degree 48 minutes. This is the direction. Okay, direction of the flow. Just to remember the formula, tan theta is equal to v divided by u. Substitute the v value and u value, and finally we can easily get the theta value. So next problem. If for a two-dimensional potential flow, the velocity potential is given by pi equal to x into 2y minus 1. So here note down, this is not a stream function, it is velocity potential function. Okay, determine the velocity at that point pi 4,5. Okay, full stop. Determine also the value of stream function psi at the point of p. Okay, so here we have to calculate only velocity potential. Okay, easy enough. So pi is equal to x into 2y minus 1. Okay. So what is the velocity component in the direction x and y are? So u is equal to minus dou pi divided by dou x. Dou pi divided by dou x, which is equal to minus dou pi divided by dou x. What is the pi value? X into 2y minus 1. Okay. So the partial derivation of the x into 2y minus 1 is 1 minus 2y. 1 minus 2y. So next come to b is equal to minus dou pi divided by dou y, which is equal to minus dou divided by dou y is into x into 2y minus 1. So finally we get minus 2x. So u term we got 1 minus 2y, and for b term we got minus 2x. Okay. So next, so what they asking, determine the velocity at the point 4 comma 5. Okay, so velocity at the point 4 comma 5. So here x value and y value they given. Okay, here x equal to 4 and y is equal to 5. Okay, so for u term, that means the velocity component u term, we have the equation, final equation 1 minus 2y. So substitute y is equal to 5 here. So 1 minus 2 into 5. 1 minus 2 into 5, which is equal to minus 9 units per second. Okay. Next, b is equal to minus 2 into x. So minus 2 into, what is x? X is equal to 4. Okay. Which is equal to minus 8 units per second. Okay. So this is the u term and b term. We can easily calculate. So if they given the coordinates, means directly substitute. So they are actually, what this coordinate indicates means they asked the what is the velocity component at that point only. So we have to calculate, we have to adopt that coordinates. Okay, in that u term and b term equation. Okay, so here you can see u is equal to 1 minus 2y. So for y, we have to substitute the y coordinate. So what is the y coordinate here? 5. For b term, we got minus 2x. So what is the x term here? 4. Okay. So u is minus 9 and b is minus 8. So for the resultant velocity is equal to root of u square plus b square. U square plus b square. This is the formula for the resultant velocity. So the root of minus 9 square plus minus 8 square. So minus 9 square, we know that it is plus 81. Okay. And minus 8 square means 64. So 81 plus 64. We can take the root, means finally we get an answer 12.04 units per second. So this is the answer. Okay, now? So next we will see the one more problem. Now you can see this problem. The velocity potential function is given by pi is equal to 5x square minus y square. So this is the velocity potential given, pi. Calculate the velocity components at that point 4 comma 5. So this also as per the previous problem. So they are asking not at the 0 comma 0 point, not at the starting point. Please remember, we have to calculate velocity component at 4 comma 5. At that point, at that coordinate only we have to calculate. So let us do. So this is the pi value, 5 into x square minus y square. We know that it is given in the question. Next, what is the partial differentiation of this value with respect to x? It is nothing but 10x. So 5x square minus 5y square. So 5x square means partial differentiation how much? 5 into 2, 10. Okay, so 10x. Next to 5y square, dou pi divided by dou y, which is equal to minus 10y. Okay, so now the velocity component formula u and b. Okay, u is equal to, what is the equation? We already seen, minus dou pi divided by dou x. Okay, minus dou pi divided by dou x. So the dou pi divided by dou x we already calculated, it is 10x. So we have to put only minus. So minus 10x. Okay, previously we have to put minus. So minus 10x. Next come to V. So V is equal to minus dou pi divided by dou y. Okay, minus dou pi divided by dou y, which is equal to minus 10y. Okay, minus 10y. So already in the equation minus is there. Okay, so in the formula one more minus is there. So minus into minus plus. So which is equal to plus 10y. Okay, so for the u term, that means velocity component in x direction is minus 10x and velocity component in y direction is 10y. Okay, so therefore the velocity, what they are asking on which coordinate? They are asking velocity component at 4, 5. Okay, so here x is equal to 4, y is equal to 5. So you can see here for the u term. So u term is nothing but in x direction. Okay, you can see here x is here, but v term y is there. Okay, so now for the u term, minus 10 into 4. Okay, substitute x equal to 4. So what is the answer we got? Minus 40 units per second. Okay, now for the v term, the y is equal to 5. So 10 into 5. So which is equal to 50 units per second. So this is the final answer. Okay, now student. So I hope all of you understand this type of problem. Okay, so whatever the equation, whether it is a small equation or a big equation, that velocity component, you don't bother about that. If you know that the partial differential equation, how to convert means, this type of problem is very easy. Just partial differentiation, if you do means, directly we can get the answer. And also the velocity component point they given means, substitute that point in x comma y, we can get the answer. If in the previous two problem we seen only 2 dimensions, sometimes they given 3 dimension also, that means z term also. So no problem, if they given z term means w term also will come, that's all. Like this u and v, w term also will come, that's all. Okay now student, so up to this fluid kinematics is over. Okay, so in this fluid kinematics we will discuss what is meant by kinematics, what are the different types of flow, and continuity equation in 1 dimension, and mass rate of flow, continuity equation in 3 dimension, velocity potential function, stream function with problems. Okay, so this is the very easy chapter, fluid kinematics. Okay, so up to this, today's class over. Thank you.